Hello everyone, welcome to this video on list comprehension by data science in this Python full course from beginner to advanced. So far we have discussed a lot of data structures, we have solved few problems as well, and we have been exploring Python a lot. One of the major concepts which is used very much in when you will do any data science problem, any data engineering problem or DSA question is called list comprehension. So in most of the places this is not some syllabus, not some specific lecture, because it is an intuition, it is a concept, it is not some topic in most of the cases. So you won't find a detailed explanation about these, how list comprehension actually work. So in this video I'm going to walk you through as a chapter what is list comprehension, how to create, what is the intuition behind list comprehension, why do we even need it. Okay, we have discussed in one of our previous video that how to create a list using list comprehension, and after that I shared this assignment with you guys on 13th of July, which contained 3 questions, 2 on list comprehension, 1 on dictionary comprehension, and most of you were facing difficulty that how to exactly solve this particular thing. So in this video, what we'll be doing, we'll be first discussing list comprehension, the concept, the intuition behind list comprehension. I will say, okay, once we do this, after this, we will be solving these 3 problems, which I have just shared. So we will not only solve how to code, we'll understand how to build the architecture to basically how to build the framework in mind so that you can actually code, because 90% of the time it's about the building the framework. Coding is just 10%. Coding is very simple, but it's about building things in your mind. So without wasting time, let's start with the list comprehension. Okay, so let's start the video on this. Assume there's a Sunday, you are sitting at home, and what happens that your mother comes to you. Suppose you are sitting at your home chilling and watching some TV, and your mother comes here that, okay, hey son, why are you sitting like this? Go to the market and suppose, I'm sorry for my poor diagram. So let's see, she says that, okay, have this bag, create a get me fruits from the market, and which are less than rupees 50. Okay, so you are forced by your mother to go to market, explore the market, and get those fruits which are less than rupees 50. Okay, so your weekend is ruined now because you were watching Netflix and your mother came and gave you this bag and asked you to create a list of items. Now what happens that you go to suppose any grocery store, or you explored multiple grocery store. So what happens, suppose there is store 1 here. What you see is that there is apple, there is orange, let's say there is guava, and there is watermelon. And so you can say that this is A1, this is O1, this is G1, this is W1. This is for 30 rupees, this is for 50 rupees, this is for 70 rupees, and this is for let's say 20 rupees. Okay, similarly there is shop S2. It also contains the same elements, that for example but it has let's say some other name, A2, O2, G2, and W2. Okay, and what it has suppose for 20 rupees, it has for example, let's say 40 rupees, 45, and let's say this is 35. And there is S3, and in S3 you have for example, let's say this is A3, this is O3, this is G3, and this is W3. And you go, you check 30, you check 70, you check 80, you check 90. Okay, so these are the options available. So what happens, you take your bag, this is your bag with you, and it is called, you can call it a list. So presently that list is empty. Okay, presently that list is empty. So what you will go, you have a universe of you have a universe of items. Okay, you don't want all of the items. What you want, there is a condition that you want to only list down those fruits which are less than rupees 50. Okay, so initially this list is empty, what you have. Now you go to shop S1. Okay, you explore various things. Now you see that, can I buy apple 1? Yes, I can buy because it is less than 50. Can I buy O1? No, I cannot buy this. Can I buy this? I cannot buy this. Can I buy this? I cannot buy this. Okay, so what you did, you wrote down A1. Okay, you added A1 to your list. So technically what you did, you came to S1. First of all, you checked this one, this, then you move to this, then you move to this, then you move to this, right? So you explored each of the item individually. Remember this keyword. You went to first, then you went to second, then you went to third, then you went to fourth. Okay, this is what exactly we do in coding when we write down for a in. For example, those who remember, we do like for a in x or in some number. What we do, we iterate for what is a here, a0 iterator here. You have just named it a1. So you are exploring for a in this list s1. You are exploring, first check this, then check this, then check this, then check this. Okay, now, okay, after this you came to s2 with your list. Now your list is not empty, you have a1 there. Okay, now you will explore again items here. So you will buy this one, you will buy this one, you will buy this one, you will buy this one. So what you will do, you will add a2, you will add o2, you will add g2, you will add w2. Okay, now again you will come to s3. You will take this list. So you already had a1, you had a2, you had o2, you had g2, and you had w2. Now what you will do, you will check, can I buy this? I can buy this. I cannot buy this. I cannot buy this. I cannot buy this. So you just added a3 here, and this is your final list. This is the list that your mother asked you to create, and this is something that you created. So what is this method? This method is called list comprehension. Okay, this method is called list comprehension. I'm just telling you the intuition behind how it works. So what happens, that there is a universe of things. You don't want everything in your list, right? You want to customize your list. You don't want everything. So what you will do, you'll come to this universe with your empty list initially. Okay, and then you will explore each item. You will go to first element. You have two decisions to take. Either you will accept yes or no, correct? So when you go to first item, you will see yes or no, yes, no, 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 yes, 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 no, 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 no. And whatever are yes, you just add them to your list. This is, again, I'm saying this is the intuition behind list comprehension. So now let's just, and I'll just show you a similar example through a code, what we generally write in a list comprehension code. So in this, for example, let's say there is a universe list of numbers. So for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and suppose let's say 50. Okay, you have 50, you have first 50 natural numbers. This is the universe. This is the universe, you can say. Okay, now you want to create a list. You want to create a customized list out of this. You don't want everything in your list. You want to create a customized list, which is called L, or you just name it list. So initially that list is empty. Okay, so to create a list comprehension, what all you need? You need first of all an item or iterate. You need an item, that what exactly you need to add in this. Okay, iteratum you say, or you say iterator. Okay, so you can call, you need an item or iterator that you need to add to this. Second, you need a condition. You cannot add everything to this, right? Otherwise it will be just creating like, I mean, you can of course you can take out all the elements and create a new list as well, but ideally you need to provide a condition that, okay, I need to select all, or I just want even numbers, or I just want odd numbers, or I just want prime numbers. Whatever your condition is, you need to provide that. Okay, so second is your condition. So these are the these are two items in a list comprehension. So what is the architecture, or what is the architecture of the code of list comprehension is, suppose you write down that list equal to, you do like this. So there is an expression that you need to basically item that you need to add. Okay, then there is a for keyword. After this there is a for keyword. This signifies that you are starting to loop, you're starting to go window shopping. So it means you're starting to go window shopping. Now you create an iterator for this, like for item. So this is the item. Okay, and same item you'll create for item in. and what will be in after n will be your universe. So this is your universe A. So you will say for item in A. So what exactly this code is doing, when you now close the list, what this list is doing for item in A, so it is creating an instance, an item I here. Okay, for item in A, it will go one by one. First it will go to this, second it will go to this, third it will go to this, then fourth this, something like this. It will iterate over each element, which we exactly did in the shopping example as well, right? And for item in A, item, it means that this is your final list. This is the final list that you want to create, final element of list. So you don't want any operation, you just want item. Otherwise you could also write down that item into 2 means you for every item in this list, create a square of this list for item in A. Okay, so what you're doing, for every item in this list, create a new list which is item into square. Okay, so now let me explain you through a simple code as well. So just let me zoom in a little bit so that you guys can understand. Okay, so let me create a universe. First of all, let's say create a universe list. So universe. So let's say universe is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so let me have numbers till 15. And one more thing I missed here, which I would like to add after this. So after A, there's a comma, there's an optional statement of condition, which I just spoke here, condition. But condition is optional. If you don't provide a condition, it will just copy the whole list here. So I'll speak about that as well. So just let me navigate through it. Okay, so let's say this is my universe. Okay, I've created a list. Now what I want to do, just imagine this there. I want to create a new list for item in A. So what I'm doing, let's say I'm creating a new list, L list is equal to. So what I will do, that let's name that element is something like A. Okay, A now starts keyword for A in universe. So what are we doing? We are creating an imaginary virtual, we're creating a virtual variable A. Okay, this is a virtual variable because we have not mentioned, it can be A, it can be I as well. You can name it anything you want, because you are creating it virtually. You have not mentioned anywhere, so it can be A, it can be X, whatever you can say it. So for I in universe, so first it will execute this step for I in universe. So what it will do, iteratively it will go to 1, then 2, then 3, then 4. That's how a loop state for a for loop works. Okay, for I in universe, what you will do, print I. So what is your final result? I want I, or you want something else? Okay, now let's do this, and now let's print list. So when I will do this, I have got the list. Now let us say I don't want to just copy the numbers, I want to square them. So what I will do, for I in universe, so you have to read like this: for I in universe, you want I or you want I square. For example, let's say I want I square. So I will just write down I into 2. Okay, so I have got the square. So whatever operation you want to do, it will be done in the first part. And this is the second part, which is for universe. And the third part is condition. For example, let's say you just want even numbers. You just want square of the even number. So what you will do, if I, which is the I percentage 2 is equal to 0, it means I'm only getting the even numbers. Okay, and I want square of only even numbers from this list. So now if you do this, you are getting only 4, 16, 36, 64, 100, 144 and 196. Right? So this is how a basic list comprehension is done. Now just understand, it has 3 things. Again, let me just come back here. Let me just clear board and explain you the finally. So how the structure will look like of any list comprehension is equal to list. It will have 3 elements. It will have First of all, it will have that item that you want to create, item or item that you want to add, that you want to add in your list, that you want to add in your list. Okay, now it can be anything. It can be anything. You want any operation, you just want the same number, you can do anything. So this is the first part. After this, for item in, and let's say there is some word, it could be a list, it could be a tuple, it could be anything that you need to provide. Okay, so this is what you need to add. This is the loop that you are running. It has 3 parts, and the third part comes, that is the condition part. If item, and like whatever condition you are putting. So this is the condition part. This is the condition part that you need to understand. So overall, this was the explanation of a list comprehension code, how it works, how you basically, you have a world, of elements, you have a world of elements, so like a lot of things are there. Okay, you don't want everything, you may want everything, but you may not want everything. You want to create a customized, thing out of it. Okay, you want to create a customized list from this. This is world, and you want to create a customized view of it. So what you will do, you'll iterate over each element. First you'll go to this, then you'll go to, so first you will go to this, then you'll go to this, then you'll go to this, right? And by going through each of the condition, you are putting some condition as well. By going to each element, you are checking some condition as well. If that element satisfies, you will put that into your customized list. If that does not satisfy, you will cancel it. You will add it, you will cancel it. Okay, and by this way you will be able to create a list, that is your list comprehension, So this was the intuition without coding much, that how list comprehension works. So you really need to keep this thing in mind before solving any question. And this is the general architecture that you need to have in mind. So far we have discussed about the list comprehension, the intuition behind the list comprehension. I hope it is clear to you that how list comprehension works. But how do we apply this concept to questions, right? Now we have already shared a lot of questions on our assignments and all that. You can go and check our LinkedIn page where we post daily questions. In this particular video, I'll be talking about 3 advanced questions which we posted on July 13. And most of the people were not able to solve. So before you move ahead, let me tell you that these are difficult questions. If don't consider them as your first practice question. So first solve some easy and medium level questions, then you come to this. Okay, so because this video I have created on special request, so that I explain you how to build the intuition to solve these kind of questions. So let this not be your first question that you are solving on list comprehension, otherwise it will be a little challenging for you. So let's talk about the first question. The first question says that given a nested list data, you have some nested. You know what is called a nested. So there are 3 types of things. If I tell, so there can always be, for example, let's say this is a list. Okay, now what happens? A list contains elements, maybe A, B, C, or some number 1, 2, 3. These numbers are called elements. We call these as elements. Okay. Now what happens? A list can be of multiple types. So for example, a list can be of type element in a list. Okay, element in a list. It can be of this type. And what this is this type of list where you have some characters or you have some numbers, something like that. That is your okay. So this is your type 1. This is your type 1. So let's see if the type 2. What is type 2? Type 2 is, for example, it can be a list, or it can be a tuple, it can be a dictionary, anything in a list. So how it looks like, let's see. So how for example, a list in a list, how does it look like? It looks like something like this, and its elements actually are list itself. Correct? So it's like this. So this is list in, this is what? This is list inside list. This is list inside list. So you have to, whenever you see a list, you have to ask 2 questions. First of all, what is the primary element of that list? What is the primary element of that list? Okay, is it a list, or it is a tuple, or it is some dictionary, or it is some number, or you can say some element, right? Some element like number or a character, number or a character. Okay, so this is the first question. Please note it down. You need to ask this question always. What is the primary element in your list? Okay. Second, what is your question? Your question wants you to access a number or a character, or it wants you to access a list or tuple or something. Okay, so these two things you need to ask yourself before the question. We'll be using this approach while solving the questions. So I'm just telling you, always ask whether a question contains is asking about fetching elements directly, or it is asking you to go in a nested list, where is a list inside a list inside a list, something like that. Now there can be as many types as you want. For example, let's say you create a type 3 where it is list, in list, in list. So there are like three nested ifs. So how will this look like? So let's say this is my overall bigger list. Okay, there's a bigger list. Now there will be a smaller list. So there will be a smaller list like this. So this is the smaller list L1, comma smaller list L2. Okay, and smaller list L3. Okay, so this is like this. So this is your L1, this is your L2, this is your L3. This is how your small. So this is your big main L, this is your main L, and this is your L1, L2, N3. And inside this also there are further. This is a list. This is a list. So this is like, you can call it L5. Let's say call L4, L5. Then you have another list. So for example, L6, L7, and L8, L9. Okay, so you can create as many combinations you want. Even you want to go further than this. This is called list, nested. This is called nested. List inside a list inside a list. There can be as many things as possible. So this question particularly speaks about a nested nested. So what we need to do, first of all, we need to check what is the primary element of that particular list and what are they asking us. So please keep this in mind. I will be talking about this while solving the question. So now let's read the question. So we have a list. For example, this is the data which is present. So let me tell you, this is the solution for this. Okay, I'll explain you. P for A. Now right now you will not understand what is this. Okay, so I'll explain you that. Now for example, what they want, that in this list, doesn't matter, wherever you see a vowel, you just print that vowel. For example, let's say I change this to, I. Okay, A, E, I, O, U. So let's say I change it to U. Okay, and when I run this particular thing, I get A, U, E, I. Okay, so the question is asking, in this nested list, doesn't matter wherever your element is lying in, doesn't matter it is inside a list or further it is entered inside another list, I just want to print all. Okay, so this is what they are asking. Now let's do one thing, that now let's remove this particular thing. Now, so we will code this from scratch. So let's go here. First of all, try to build this. So now the first question, remember what did I ask you first? First you need to ask the first question that I told you, check what is the primary element of this. What is the primary element of any particular list? How will you solve it? So how you solve it, you just check the first element. You take L, you type 0. You'll get to know what are you getting. Is it so for example, you do like this, P is equal to L of 0, and you get the type of that particular element. So what I'm doing here, so let's do one thing. I create P is equal, let's say do something like P is equal to data, because presently just by looking, I don't know how many nested conditions are there. Okay, so I have to build a general solution. So I'll do data equal to 0. And when I do this, and when I print, for example, now I check type of P. It is a list. So what do we get to know? That the main element inside this is a list. Okay. So this is so how this is structured, that this is a main list. Okay, this is a main list. Inside this there is a list of list. Okay, so we know this much only, that inside this there will be few lists. This much we know. Now we don't know how many lists are inside it, but we know this one, that this is a, right now this is a type this N1, L2, L3. So this is a case where this is list in list. Okay, this is this type of question. Now come here. So now let's check. So for example, let's say if let's say print, let's say if I have to print p, what do I see? Print p, I am seeing a list. So this is a list of list inside. Okay, so this is a list of list inside. So technically if we see, there are two lists. So this is one list and there is another list which is inside it. Now what I do that okay, now let's me access what is further world. So let's say this p is a list. How is this p segregated? So let's do x of 0, p of 0, and keep it as x equal to p of 0. And now let's check type of x. Again, it's a list. So it is a list inside it. So let's do one thing, print x. So if we print x, we see that it is further a list, correct? So x is further a list. Now if I do another 0, for example, I get to know that now if I have to print x, type, let's say I want a type of x, I will see string. So what do I see? There is a list. In list, there's another list inside it, and in this list there are strings and strings. Okay, so list in list, inside this there is another list. Okay, inside this there is another list, and this particular list contains strings. This particular list contains strings. So this is how things are structured. I'm telling you in this detail how to decide. You have to explore which type of list is this. Okay, now comes the second question. What is my condition? My condition is asking me that I want to filter the, so what is my question? My question says that I want those elements. I want using list comprehension, create a new list containing all vowels from the data. So basically we want to access this string so that we can decide whether this is a vowel or not. Okay, so we want, the condition says that access the strings, okay, condition is this: first access the strings, check if it is a vowel or not. Okay, check if it is a vowel or not, and if it is a vowel, add it to the list. If it is a vowel, add it to the list. So this is what they are asking. It is a list in list in list, and then it's a string. So this is this type of question. So I've explained you this in depth because you need, when you're solving question for the first time, you have to prepare a blueprint in mind. Okay, now let's move ahead. How do we solve this question now? Now, for example, so I know that when I do, for example, let's say I will, so first of all, what will I do? I'll create my list comprehension, very basic one. So what was my basic list comprehension? It was, remember, list is equal to what we do in a list comprehension, we do an item, okay, for item in universe, okay, and then we put a condition. So we have first part p1, we have part 2, which is a for loop, and third is the condition. Okay, so let's start from the basic. Now we want to access, actually what we want to do, we want to access the strings. Now initially, let me write down the first basic. Now let's say I start here, I just write down a simple code that I do list is equal to, now let's name it item for item in data. Okay, if I and I put the condition, so if item is equal to, if item in you do A, E, I, O, U. Okay, if we write it down like this, Let's run what it says. Right? So what is saying, what we are technically doing for we are checking, comparing this in the, we are checking item in this, first we are matching with A, then we are matching with E, then we are matching with I, then we are matching with O. But what is this item? This item is presently a list. So the error says string requires string as left operand, not list. Because what is happening right now, I am just taking down a list and comparing it with this. Okay, so I want to access the elements. I want to access the elements string, not some list. So what happens when I write down first? For example, here, let's say I write down my first condition. So let me just refresh it again. Okay. So what is my first condition? I have my main list here. Okay. I have my main list here, which comprises of two lists. It comprises of two lists, L1 and L2. Okay. Now, can I pass the condition to check whether A, E, I, O, U here? No, because this is a list. I cannot compare a list with a string here. So I need to go further down. So this was my level 1. So whatever code I just wrote here, I was doing for item in data. Okay. So what I'm doing, I'm checking for, this is the item, for item in list, for item in this, I'm just checking if that item is in AU, OU, and if it is there, just print that item. So it will not go. So now what I need to do, I need to further break this individual list as well. Okay. So I need to break it L3. I need to break it L4. Similarly, I need to break it down in L3. I need to break it in L4. Because see, there are total 4 lists. This is the list 1. This is the list 2. This is list 3. This is list 4. So how will I write it down? Now, this list. So for example, we named it for item in data. So this is my data. This is my data. And this is my item. Okay. So I'm saying for item in data, because this item is present inside this data. So that's why for item in this data. Now I want to create a new iterator. I want to create a, I can, so what it will be, so we can name it item 1. And item 1 is inside this. Okay. We will, because item contains 4 elements. So this item will iterate. It will first check this. It will then check this. Then it will check this. Then it will check this. Okay. So how will we write it down? For item 1 in item. That's how you loop in. So what are we doing here? So for item in data, okay, we did this much. Okay. Now right now I'm removing the if condition. So let's remove this if condition right now. We want to access the elements. Now what if, so we have already explored for item in data. We are here. Now we want to go one step down. Item 1 should be in item. So what we will do in data, after this we will write for item 1 in item. Okay. So what is happening? Now we are iterating item 1 in item, and item 1 contains of 4 elements, 1, 2, 3, 4. Okay. And what is item 1? Item 1 is again a list. So we are printing now item 1. Now if I print, let's see, now if I print item print list, let's see what comes. I get a list of lists. Okay. So I have not, still I cannot put that condition, because let's say I put the condition now, if item 1 in A, E, I, O, U. Okay. This will not work even now, because it is still, item 1 in A, I, O. It will still not work, because string requires string as left, not a list. Even now we are comparing with a list. So we need to drill even further one level down, so that we can get access to elements. So what we will do, we will basically further put it down here. So we'll further break it, and whatever strings are present inside the list. So AUC. So we'll break this this into AUC. We'll break this into whatever its name is, DEF, GHI. Okay, so we'll break it into DEF, GHI, 𝐿. Okay, we have now further broken them into various levels. Now this is string, these are string. Now this is not a list, now this is string, and on this I can put my condition. So here I will assign a new iterator, item 2, I can call it item 2. Now item 2 is of type string, correct? And now I will again do for so I will write it, I will write down there for item 2 in item 1. Okay, for item 2 in item 1 I'll put a condition. So I'll write it down that, okay, for item in item data. So while I'm writing this, I am here. Okay, now for item 1 in item. So what we are doing, we are checking item 1 in item, and now the third level is item 2 in item 1. So what we'll again write it down for item 2 in item 1. Okay, now what we want to print, we want to print item 2, and item 2 is of character type, and I will just, let's replace this, right? Let's remove this now. Now when I print list, I see I have got access to all the characters. Now I can easily put my condition if item 2 in AEIOU, and I'll print this, I'll close this. Now when you write down this, you will get the solution. So this is what this is called a tree. This is called a tree algorithm. Basically what we do in future when we solve DSA questions, right? This is a DSA question. Actually I just introduced here, this is a DSA question on list comprehension. So we started at the top of the tree, then we went L1, L2, then we further went L3, L4, then we further deep dive into this, and at every step we create a new iterator, and that iterator will check it with the previous one. And so this is the question. Now if you, without knowing this architecture, you cannot write down this code. Just imagine if you don't. So first you have to visualize this tree inside your mind. You need to visualize this in your mind. Once you can visualize this in your mind, then you can easily write down this code. So coding is nothing, it is just a one-line code, but building this architecture in mind is something very important. If you still don't understand, please comment on the video and we can have a call to discuss that how actually we solve this. But I think this is fairly easy. Try to visualize this, try to draw in your diagram in your notebook, and try to explore at all level. First try to break by writing just a simple thing, by just writing for item in data, then then try to add further things, then you will get to know. So this is called a tree. This is called a tree algorithm. This is called a tree algorithm, which is a part of DSA. Okay, so please now I think explanation should be clear, but still if you don't understand, let me know. So now let's come to the question number 2. It is also a similar question which we discussed in the question 1, where we have a nested list. Today we have a nested tuple in this particular question. So given the nested tuple info, you have some nested tuple you don't know. First of all, see, nested could be anything, it could be any level, so we don't know right now. Using the tuple unpacking and list comprehension, create a new list containing the ages of individuals whose names start with D. Okay, so this is the condition. So you have some tuple, some big tuple is there, and you want ages of individuals whose names start with D. So let's start building the architecture of this particular question. So remember, first question that you need to ask yourself is, what do you want to access? Do you want to access a string or number, or you want to access a tuple, right? So that you need to decide first of all. So let's go around building this thing that we need to decide whether we have to do it A or it has to be B. And the second thing, we need to start building the tree, because all these are tree questions. So whenever you see nested question, these are tree questions. So you have a tuple at the start. Now we will start building this particular tree by going downwards. So let's find the question. Now we have this tuple info. Now we don't know what is which type of tuple it is. So first let's identify which type of tuple is it. If I do info and then I do 0, so how to identify? See, what you will do, will create an instance of this class info, and then you will do 0. Okay, now you'll do a print, then you will do print x, and then you will do type of x. Okay, so let's see what happens. Now first of all, we are just trying to access the first element of this tuple. So once we do that, we'll start building the tuple here. So let's see, when I run this particular code, incomplete input, for example, info x is equal to info, sorry, so this thing is not clear. Okay, so we see that we get a tuple. So it is a type of tuple. So the first element of info is tuple. So what does it means? This whole tuple, it is a tuple inside tuple. So for example, there is a big tuple here, and inside this there will be some tuples. So this is a tuple of tuples. This much we are clear by running the first code. So let me just zoom it out. Okay. So this much is clear that this is a tuple of tuples, because now if I see, if I do a 1, I will get Charlie David. So I get Charlie David, then I get Alice Bob. So this is first tuple, this is second tuple inside it, this is the third tuple inside, this is the fourth tuple inside it. Okay, so this much is clear to me, that okay, this is a tuple inside a tuple. So so let me just remove this thing. Let me try to create things from scratch. So how is it looking like right now is that it is a tuple, it is a big tuple, and then it has multiple tuples inside. So this is a tuple 1, this is a tuple 2, this is a tuple 3, and then there will be tuple 4. So there are multiple tuples inside it, T1, T2, T3, and T4. Okay, now after this we need to check, we need to do a further 0, because this tuple is again a tuple of tuples, right? So if I do 0, after 0 I do another 0, I'll get to know that this is a tuple. Again it's a tuple. So it's a tuple inside tuple. And after this, if I do another 0, what do I get? I get string. Okay, so it is a tuple inside tuple, and then it's a string. So how does it look like? This is a tuple inside tuple. Inside this there is another tuple. Okay, there's another tuple inside this, and inside this tuple we have a string. Inside this tuple we have a string. So this is how you identify. This is the approach that you need to check, that which type of tuple is it. So you do 0 0 0, you get till you get access to the base element, that is your string. So now we are clear. It's a tuple inside a tuple inside a tuple inside a tuple. And so this is the level 1, this is the level 2, and this is the level 3. Okay, now let's move to the question. Question asks us ages of all individuals whose names start with D. So what it wants, that it wants the ages of individuals whose names start with D. For example, it wants David, it wants Diana, it wants Derek, it wants Daniel. It does not want Emily. So my question to you guys is this question asking to access a tuple, or it's asking to access just a string? If you say, so let me refresh this. Okay, so my question is this question asking me to, first of all, ask yourself as well, is it asking me to access a tuple from outwards, or it wants the elements of a tuple inside a tuple, or maybe a string or something else? Now if you see, the question says you want ages where name starts with D. So there are two conditions. You want age, but where name starts with D. So based on these two criteria, so based on this criteria, you want this, correct? So based on the criteria, so it is something you have left criteria and you have left thing and right thing. Based on R, you want L. This is your objective. Okay. So technically, you don't want to access the elements directly. You want to talk to tuple. You want to tell tuple that, hey tuple, you have two elements, element 1 and element 2. What you have to tell me, return me your element 1 if your element 2 has D in it, correct? So here you're not talking to elements directly. Here you are talking to tuple. So in this particular question, that the process that we try, architecture that we try to build, that what you need to do, you need to access a tuple directly. You don't have to access to element, because for example, let's say if you access an element directly, then Alice 25, these all will come to same level. You don't want that. You want to access a tuple. And second is your condition where name starts with D. Okay. So let me create a tree of this particular question. This is a tree based algorithm. So what is this question about? So first of all, we have so at start we have a tuple. Okay, let's say we have a tuple. It is a tuple of tuples. So what is there? There is T1, there is T2, there is T3, and there is T4. Okay, so it is like this: T1, T2, T3, and T4. Okay, now each of these tuples, so if you see, there's T1, T2, T3, T4, and each of these tuple has further two tuples inside it. Each of these tuple has further tuple inside it. So for example, so it is T5, it is T6, it is T7, it is T8. So this is T9, T10, and then it has T11 and T12. Just let me cross check if I'm doing it right. I think that I did a mistake. 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So there are 4 tuples and each is having 2 inside it, right? So 4 and each is having 2. So there are total of how many tuples? Tuple 1, tuple 2, tuple 3, 4, 5, 6, 7, 8. So there are total 8 tuples. So first of all, from 1 we went to 2, and from 1 we split to 2, from 2 we split to 8. Now if you break each tuple independently, now you can access the element. So what are the elements? Let's say there is Alice, then there is age, similarly, and so on. Similarly, you have like elements. Now you can access this is the element level. This is the element level. So what you have to do, you have to start from the top. You have to keep breaking till you reach the element level. Now let's name everything differently. So let's say this is tube. Let's name it tube. Okay. Now let's name this tube 1. This level is tube 1. Or we can say, let's say level 1. Let's call it level 1. Level 1. Let's call this level 2. Okay. Let's call this level 3, this particular part where we have 8 tuples. This is level 3. And this is level 4, L4. So how are we naming them? This is L1, this is level 2, this is level 3, and this is level 4, where we have final characters. Now, as per the question, what do we want to access? Do we want to access these elements or we want to access this element? So the answer is we want to access this tuple, because this tuple T5 contains name and age. Name and age. So once we get access to this tuple, we will put a filter that, okay, return me name from this tuple where age is greater than, just let me cross check what is the question. Sorry, where name starts with D. So we have to return age where return me this where name starts with D. So we have to access to this particular thing, not this, not this, not this, not so. So this is the main intuition that you need to first you create a tree like this in your mind, and then you try to identify which thing do I need to access. Do I need to access this, or this, right? Now our structure is ready in our mind. So what will I do? I will start the coding now. So let me just okay. So I will start the coding now. Let's go here. So what are we doing is let's create a list. So let's create a list. Now let me remove this. So let's say L is equal to, for example, now if when I am at the level 1, so what is this? Level 1 is L2 in L1. Okay, this is my L1 where I have the list of tuples, and L2 is my individual tuples. So what I will do, L2, I want to for L2 in L1. Okay, and then when I do print L, so so for L2 in L1, okay, so when we do this, L2 will iterate. First it will check T1, then it will check T2, then it will check T3 and T4. And what do I need to print? I need to print the whole L2. Now when I do print L1, so L is equal to, wait a second, L2 for L2 in L1. Sorry, so L1 is your info. So let's just change this name to L1. Okay. Now, so now you have got this particular information. Now we have reached here. Now presently we are at this level. Okay. Now I want to go to this thing because I want to access T5. So what is T5? L3 in L2. So L3 in L2. So what I will do, I'll write down for L3 in L2. And what do I need to print? I need to print L3 because I want to access L3, which is the tuple finally that we need. And this is the list of tuples which is present there. Okay. So now we have accessed T5, or you call T6. Now we can through L3 we can iterate through each of the elements. Okay. So now this is my architecture code so far. Now let's move to the next part. Now when I am at this, so let me just restart. Let me just, okay. Now what do I have? I have list of 8 tuples. I have tuple 1 where we have name and age. Then we have tuple 2, we have tuple 3, and so on. Okay, and this tuple is by the name, whatever its name is L3. This iterator, which is iterator that is going, its name is L3. Now remember, we can also write down that A comma B, or we can write down name instead of L3 if I want to access the elements remember the tuple class where I showed how do you access the elements inside a tuple. What you do, you can also write down instead of L3, you can say name. You can name it anything. I'm just calling it name comma age. Okay. So instead of directly writing L3, we can also write down name comma age, because through this I get to access the elements inside this particular tuple. So what I'm doing here, instead of L3, I will just write down name comma age. Name comma age. Okay. Now let's try to print. So when I write down this, what will be there? I can print name comma age, something like this. But it will give me error because I need to provide the parenthesis. So if I do something like this, I'll still get the same thing. Okay. Now I'm accessing each of the element and I'm printing each of them. Let's say I only want to print name. So what I will do, I'll remove the age from here, and I have only the access to names here. So this is how I am printing the names. Now comes the condition part. The condition says whose names start with D. I want ages of individuals where name starts with D. So eventually we want to print age. We don't want to print name. We want to print age. Okay. But we want ages of whose name starts with D. So what we will do in L2, now here will come the condition, the if condition, that name has to start with D. So what will we do? If name, now remember, for example, how to access a string. Let me give you an example. For example, let's say you're given a string like this. Let's say X is equal to data sense is a platform. For example, let's say you are given something like this. Now if you want to access element, you want E, you want A, or you want T, how do you do that? This is exactly similar to slicing that we used to do. X0, if I do 0, I can get access to element of a string, I can get D. Okay, so and if I put X1, I can get access to A. If I do 2, I can get access to T. Okay, so this type of thing we can do. Now question says, is first name should start with D. So as simple as that, if name, now I'm accessing the name, and if I have to just know its first element, so what will we do? Name, this 0, and you want to check if it is equal to D, so you'll do double equal to equal and D, and now you close the comprehension. And now when you print this particular list, you will get the ages of the people, 28, 26, 32, 27. You wanted to print this, you are able to get this. Or if instead of age you just want the name, you can get the name as well. So this is the overall architecture of the question, that first of all you need to decide which particular, what is the tree, which type of tuple is it. After that, what you want to access. Do you want to access a tuple or an element? So in that tree, identify which particular element you want to access. Once you do that, then start writing the code. Okay, and once you, then it will be it's just simple. Again saying, it's a one line code, right? But people spend like 15-20 minutes or even 30 minutes while they understand this. Okay, so first step is to decide which type of tuple is it, which type of tuple or a list it is. Once you decide that, then ask yourself which. So let me just create the general architecture once, the solution once again. First of all, do get to know type of tuple or list. Okay, as I mentioned. After that, create the tree, then assign iterators. You can assign like iterators. Okay, create a tree and decide which element you want to address. Okay, whether you want to address a tuple or you want to address a string. So that you need to decide. Once these three things are done, then start coding. Okay, so this is the step that you should be following, and this is something I follow personally in my cases. So I'll suggest you, if we will start building this habit, is something which you need to start building. Don't just jump in the code. Okay, I'll tell you, there are questions which might take even 30 minutes to think, but their code is eventually 1 to 2 line only. And how do you do that? By thinking. So that is the main objective. And I hope this solution is clear. Now the third question, it is exactly based on these two concepts only. So I am now giving you it as assignment to you. Now based on whatever you learned here, try to put that information, put that understanding in question 3 and tell me your solution. So I hope this particular video is clear to you. I hope you learned something new, how to address these questions. And please keep practicing more. This particular thing comes with practice only. And don't be blind coders. Build architecture. If you cannot build that tree which I created, then you are not the right coder. So you need to create those particular trees in mind before. Okay, I'm starting from here, then I'm going here. Okay, then from here I'm splitting myself into these three things. Okay, and then whatever things are going. So like this, you need to create an architecture in mind. So thanks again for watching the video. Please subscribe to our channel and stay tuned. This Python course has just only started. We are very close to start solving DSA problems. So be prepared, follow all the previous videos that we have shared. And thanks again for watching, and please subscribe to our channel. Thanks again.